Hey guys, so this is the second video explaining this question. Now for this question we see that the rate of acceleration is between point A and point B. Because there is a straight line relationship on the velocity versus time graph, we can use the constant acceleration equations, which we can see here. So it is useful for us to list down what we know about the situation going from point A to point B. Alright, so what do we know? For point A to point B, we know the initial velocity is equal to 0 meters per second. We know that the final velocity is equal to 25 meters per second. We are trying to find out the acceleration going from A to B. So we don't know what that is equal to. Alright, the last piece of information which we know is that the time is 20 seconds taken to travel across there. So we'll write that down here. Alright, so now we need to look for an equation which has u, v, a and t. So we can look back at our table here looking for u, v, a and t. Alright, so the equation with u, v, a and t will be this one down the bottom. So v equal to u plus at. We can rearrange this to find acceleration. Alright, and then now we can calculate acceleration. Alright, and then place that into our calculator. So 25 minus 0 divided by 20, we get 1.25 meters per second to the negative 2. Alright, so we can also do this for the rate of deceleration. So for the rate of deceleration, our initial velocity will be 25 meters per second. Our final velocity will be 0 meters per second, and the time taken will be equal to 0.5 seconds. So to go from point C to point D, we have 0.5 seconds worth of time taken. Alright, so from C to D, initial velocity was 25 meters per second. Initial velocity was 0 meters per second. Acceleration is what we're trying to find. That's going from C to D. And then our time, which we know is 0.5 seconds for that section. Alright, so we use our same equation here. I'm just going to directly use acceleration equal to v minus u divided by time and substitute values into this equation. So 0 minus 25 divided by 0.5. From there, we just put that into our calculator. Minus 25 divided by 0.5, and we get minus 50 meters per second to the negative 2. Alright, so both of these solutions, 1.25 and negative 50, these are telling us the gradient of this graph which we see at the top here. The gradient or slope of this part here is 1.25 meters per second. For every second it increases by 1.25 meters per second. For here, we have a decrease of 50 meters per second every second. Of course, it only takes this process only takes 0.5 of a second. Alright, so in the next video we'll be calculating the total displacement of the particle. So this will be the area underneath this graph here. Thank you, see you in the next video.